Je voudrais du soleil vert.
Hello, chemists, and welcome to France.
If there's one thing that the French are probably famous for, it is wine. Now, if you've ever watched a TV show or a movie and you see somebody opening up a wine bottle and then sniffing the cork, what's up with that? Why are they smelling the cork? What is it about the wine that they're trying to identify by smelling the cork? And we're going to try to explain that by looking at something called the oxidation of alcohols. Now, it may come as no surprise that wine contains alcohol, but there's different types of alcohol out there, and the type that is found in wine is something called ethanol. And ethanol has a structure that looks like this. It's two carbon atoms connected to an OH group. So here we have two carbon atoms and a couple of hydrogens connected to an OH group. This makes it an alcohol, and because there's two carbon atoms, that makes it ethanol, the type of alcohol. Now, what can happen is this alcohol can get converted into something else, something we don't want in our wine, and this happens because of exposure to air or oxygen. So if we introduce some oxygen to our alcohol, it changes. And what it changes into is something called ethanal. Ethanal is an aldehyde, and you might be familiar with this word. Have you heard of formaldehyde? Formaldehyde is that compound that they use for preserving things like in biology labs. And as you can imagine, this probably isn't good for you. And so if ethanol gets combined or reacts with oxygen, we end up then with ethanal, which is a type of aldehyde. Now, it doesn't stop here. The reaction can continue, and we end up with something called a carboxylic acid. Now, this particular structure here is a carboxylic acid, and the way that we can tell that is it's a carbon double bonded to an oxygen and an OH. And this particular one is called ethanoic acid. But it also has a couple of other names that you might recognize, some common names. One of the common names is acetic acid, which has a common name called vinegar. So wait a minute, why is somebody smelling that cork? Because if the alcohol in the wine is exposed to air, it oxidizes. It's exposed to the oxygen in the air. It oxidizes, becomes an aldehyde, and then it further oxidizes, combines with air, reacts, and becomes vinegar. So when you're smelling that wine cork, one of the things that you're looking for is whether or not the wine has been exposed to oxygen and has turned into vinegar. There's other things that sommeliers, people with very developed sense of smell are looking for, but for the rest of us humans, we're probably just trying to tell whether or not it's gone bad. Now, why does a wine do that? If the cork dries out, it can let air in. This is why people who store wine for a long period of time will store the bottles on their sides. That way the cork is exposed to the wine. That helps to prevent the cork from drying out. And if it dries out, it can crack, let oxygen in, and we end up then with vinegar. One other little nugget on this is in the human body, when you drink alcohol, it undergoes a similar metabolic process. And that is we take the alcohol and we convert it into vinegar that naturally occurs in our bodies. Now, if you could stop this process right here, then you would have aldehydes building up in your body. And as you can imagine, that probably wouldn't feel very good. And why would you do that? Why would you do that on purpose? And the reason is, if you are addicted to alcohol and you're trying to break yourself of that habit, if there was a medication that would block the pathway here, inhibit the enzyme that causes this reaction, then the aldehyde would build up. You'd have terrible side effects, vomiting and just being sick. And that might break you of the habit of alcoholism. And there's a drug for that. It's called antabuse. Antabuse inhibits this enzyme right here and causes this to build up and helps, supposedly helps people to break alcohol addiction. Now, for organic chemists, this is called an oxidation reaction. And oxidation is really just increasing the number of carbon-oxygen bonds. And so here you have one carbon-oxygen bond. Here we're increasing the carbon-oxygen bonds to 2. And then here we have carbon-oxygen bonds 1, 2, 3. So this is an oxidation reaction. Organic chemists would also recognize then if we go in the opposite direction, that would be reduction. We would be reducing the number of carbon-oxygen bonds from 3 down to 1.
La samba des jours avec toi, la samba des jours avec toi, la samba de mon cœur qui bat.